last thing that we're going to do is use a special formula to find the minimum sample size needed for a population proportion. So when we're asked to find a minimum sample size or to find a sample size, what we're going to be using is this formula. But we're only going to be using this formula if we have a proportion. Why am I making that clear is because there's going to be another formula for sample size in the next section that is used when we don't have a proportion, when we've got a different situation. So we're going to use this if we're finding the sample size for a proportion. So key ideas, we're finding a sample size for a proportion. And notice that's why the formula will give us n. Now you need a couple of things. If we're dealing with proportions, we almost always see p hats and q hats in our formula. We also see this e that we've seen before, which is called r, or e is called our margin of error. So the p hat, q hat, and e should all be given in the problem. However, remember, if they don't give us a p hat, we use 0.5, which means q hat would also be 0.5. And then the new part is we're also going to be having to find the critical value, the z value that we need for a given confidence level, an alpha, or significance level. So remember, let's see. What we're going to do is draw our picture and set up our formula, but let's see what we do know and what we don't know first. So let's go ahead and read through this first example. It says, find the sample size needed to estimate the number of adults who have consulted fortune tellers. Use a margin of error of 0.03, use a confidence level of 98%, and use results from a Pew Research Center poll suggesting that 15% of adults have consulted fortune tellers. So here p hat success would be somebody consulting a fortune teller. So we've got our p hat, which is our 15%. Remember, we're going to turn it into a decimal so that we can actually use it. And then remember that q hat is going to be the complement of that, which means it's going to be 1 minus whatever we got for p hat, which means we're going to do 1 minus the 0.15, which will give us a 0.85. Now let's look at the formula we were going to use. The formula for our minimum sample size needed is n equals, let's see, it was a z sub alpha over 2 squared. Then it had a p hat, a q hat, and this was all over our margin of error squared. So we've got the p hat already, the 0.15. We've got the q hat already, the 0.85. We actually already have the margin of error already. That is going to be the 0.03. So really the only thing I'm worried about finding is this critical value for z, the z sub alpha over 2, which remember is always going to require a picture of some kind. So let's go ahead and tackle that. Notice they don't give us an alpha. However, they do give us a confidence level. That is going to be our hint as to what alpha is going to be. So we're going to use our confidence level, which is 0.98. Well, we already know how to draw our picture if they give us a confidence level of 98%. Well, what we would do is go ahead and draw our picture. Confidence level, remember, they're based on confidence intervals, which means that there's 2 n's on those, which means that the 98% that they're giving me goes in the middle of those two, if it's mentioning anything about confidence or confidence intervals. That means my 98%, my 0.98 will go in the middle, which means what's going to go on the ends? Well, if 98% went in, or 0.98 went on the middle, it means that on each end, I'm going to have the rest. the other 2%, which means each n should have half of that. That's why the alpha is divided by 2. So each n should have a 0.01. That's why they said divided by 2, because you've got to split it up between both n's when they give you a confidence level. Okay, so remember the goal is to find the z sub alpha over 2 that comes from this value. But remember, I need an area to the left, which means I need all of this stuff to the left, which means not just the 0.98, but also the 0.01. So if all of that is put together, it means I'd add those two, the 0.98 and the 0.01, and that would give me a 0.99. So that means I'm going to do an inverse norm of what's to the left, which we just found, which is the 0.99. And that is going to be my z sub alpha over 2, my critical value that I'll use in my formula. Well, if we go ahead and use our formula to do this, we get a z sub alpha over 2 of 2.33. And remember, your critical value, we're always trying to find the one on the right, which means that your critical value should always be positive. So you do need to make sure that you are getting the positive version. So 2.33. Now we've got everything we can use to do our formula. So first of all, the first thing that went inside our parentheses on top that was squared is our z value, our critical value, which we just found was 2.33, so I can go ahead and input that. The next thing up top was our p hat, which is our 0.15. The next thing up top is our q hat, which is 0.85. And then divided by on the bottom is our margin of error, which was given in the problem, which was 0.03. Remember, according to the formula, the margin of error is also squared on the bottom. So the hard part and where students usually run into an issue is actually learning how to plug this into your calculator. So when we're plugging this into your calculator, you have to do this by following the order of operations. So what we'd first want to do is simplify the entire numerator. So that means we'd start by simplifying that entire top. By doing what first? You'd have to start out with the exponents first. So you'd have to take the 2.33, square that, then multiply that times the 0.15, then times the 0.85, and see what you end up with. So we were going to work with simplifying the top first, and if you plug that into your calculator, like I said, doing the exponents first and doing your multiplication, you'll get a 0.6922. But then you also want to figure out what your denominator is by doing the 0.03 squared, which gets you the 0.0009. And then if you do your division in your calculator, that's the last thing that you end up doing, which you'll get as a 769.1. However, this is talking about people or things, so we can't leave it as a decimal as 0.1. We need to round this. The question is how. And the key is that this was the formula for the minimum sample size. So it can be as small as 769.1. So the problem is, if you were to actually take 769, that would be below the minimum. That would be not enough. So what this means is, no matter what, if we use this formula for minimum sample size, we're always going to round up. No matter what, even if it's 0.1 like this. So what are we actually going to use when we round up? We'll actually use a sample size of n equals 770. So no matter what, even if it's 0.05, we're always going to round up because this is a minimum value that will work. As a side comment, remember that some of the problems in this section will not have a p hat and a q hat. So if you feel lost, they may say something like, and the proportions are not given. Then you use, again, remember a 50-50 as your p hat and your q hat.